One magazine, two weapons. Every serious military cartridge design since the invention of the metallic cartridge has made a choice between power and quietness, between the velocity that produces lethal effect at distance and the subsonic speed that allows a suppressor to function below the threshold of the sonic crack. The 300 Blackout, finalized by AAC engineer Robert Silvers in 2010, was the first cartridge designed for the AR-15 platform to refuse that choice. Its supersonic loading, a 110-grain bullet at over 2,000 feet per second, produces terminal performance that exceeds the standard military 5.56 round at close range and remains effective beyond 400 meters. Its subsonic loading, a 220-grain bullet at under 1,100 feet per second, produces a suppressed report that acoustic testing places below 140 decibels at the shooter's ear, quieter than an unsuppressed .22 caliber rimfire. Both loadings function reliably from the same AR-15 lower receiver, the same magazine, and the same bolt carrier group. Only the barrel and the ammunition change. The suppressor fits either way. That is the engineering claim that makes the 300 Blackout's lethality specific rather than general. Not that it is more powerful than other cartridges, but that it is simultaneously two different weapons in a way that no cartridge before managed to do. To understand why that achievement mattered so much that a special operations unit came to a commercial suppressor company with a formal request for proposal to make it happen, you need to understand what every previous attempt to build a suppressed military rifle cartridge had produced and why all of them had failed the same test. The 5.56 by 45 millimeter NATO round that became the standard cartridge of the AR-15 and M4 platform was designed for a specific purpose: to produce lethal effect at combat ranges with a round light enough that a soldier could carry more of it than the heavier 7.62 NATO that preceded it. It achieved that purpose. At 2,900 feet per second from a standard 16-inch barrel, it was fast, flat shooting, and effective at the ranges where infantry combat actually happened. It was also for suppressed use a cartridge with a specific and well-documented problem. The 5.56 round travels at nearly 3 times the speed of sound. When a suppressor reduces the muzzle blast below the threshold of hearing damage, the bullet still produces its own sharp sonic crack as it passes through the air. The miniature sonic boom generated by any projectile traveling faster than approximately 1,120 feet per second at sea level. A suppressor fitted to a 5.56 rifle does not produce a quiet shot. It produces a shot that is hearing safe at the shooter's position but still audible at range as an unmistakable sharp crack that carries for hundreds of meters in open terrain. For a unit conducting operations where noise discipline was the primary tactical requirement, the 5.56 suppressed was not quiet enough. It was merely less loud. The solution everyone already knew about was subsonic ammunition. Bullets traveling below the speed of sound produce no sonic crack regardless of what suppressor is fitted. A suppressed firearm firing subsonic ammunition can genuinely approach the quiet that fiction attributes to silencers. Not completely silent, the mechanical action of the bolt cycling is audible. The propellant combustion produces a low thump. The bullet's impact on a hard surface is often louder than the shot itself, but quiet enough that the direction of the shot is difficult to determine at any meaningful distance. Quiet enough that a shot fired inside a building does not necessarily alert the occupants of the adjacent room. Subsonic ammunition for suppressed use had been understood as a concept since the earliest days of suppressor development. The problem was making it work in a rifle format with sufficient terminal performance to be genuinely useful. The specific problem was energy. A bullet traveling below 1,120 feet per second carries dramatically less kinetic energy than one traveling at 2,000 feet per second or more. The relationship is not linear. Kinetic energy scales with the square of velocity, which means halving the velocity reduces the energy to approximately 1/4 of its supersonic value. The standard subsonic solution, heavy bullets in pistol calibers fired from suppressed submachine guns, had been the answer most units settled for through the Cold War. First decade of the War on Terror. The 9mm parabellum subsonic load fired from the suppressed HKMP-5SD, the weapon that had been the standard suppressed close-quarters tool for special operations forces across Europe and America since the 1980s was quiet, reliable, and utterly inadequate at ranges beyond approximately 50 meters against any target with meaningful cover. The gap between what suppressed operations required and what the existing inventory provided had been felt most acutely in Vietnam, the first modern conflict in which American Special Operations Forces used suppressed weapons at operational scale. The Army's Limited Warfare Laboratory produced a series of studies in the late 1960s that documented the requirement with unusual precision. Units needed suppressed weapons capable of effective fire to a minimum of 200 meters, with terminal performance sufficient to reliably incapacitate unprotected targets from platforms compatible with the M16 ammunition and magazine system that had just been adopted across the force. The requirement was not theoretical. MAC-VSOG, Military Assistance Command Vietnam Studies and Observations Group, the classified special operations unit conducting cross-border missions into Laos, Cambodia, and North Vietnam, was operating in environments where the sound of a gunshot could compromise an entire mission, where the noise of a firefight at night in the jungle told the enemy exactly where a team was and how large it was. The teams needed weapons that could kill quietly at ranges that exceeded what a pistol could achieve, from platforms that did not require them to carry a separate weapon and separate ammunition for the suppressed role. What they had was inadequate. The psionic suppressed M16, developed by Mitchell Werbel and used by various special operations units in Vietnam, reduced the muzzle blast of the standard 5.56 round to hearing-safe levels, while doing essentially nothing about the supersonic crack that carried through the jungle and announced the shot's direction as clearly as an unsuppressed weapon. The high-standard HDM suppressed OIMI-2 pistol, inherited from Office of Strategic Services use in World War II, was quiet but chambered a cartridge that was effective only against targets who did not know they were being engaged. The Ingram MAC-10 and MAC-11 submachine guns in suppressed 9mm and 45 ACP configurations provided more firepower than the .22 pistol, but retained the close-range limitations of pistol cartridges. The Mk22 Mod 0, the so-called Hush Puppy, a suppressed Smith & Wesson Model 39 chambered in 9mm subsonic, was designed specifically for silencing enemy sentries and guard dogs in Vietnam, and was effective at the contact ranges of that specific task. It was not effective at 100 meters. The studies written in the late 1960s identified the gap, documented it with operational examples, and recommended development of a solution. The solution was not developed. The war ended. The requirement went into a filing cabinet. The development work that followed through the 1970s and 1980s produced incremental improvements, but not the solution. The Air Force's IMP, Individual Multi-Purpose Weapon, had explored short-barreled suppressed platforms in the late 1960s, ultimately settling on the 221 Fireball cartridge, a compact high-velocity pistol round that was quiet in subsonic configuration, but limited in terminal performance at range. The project reached prototype stage and was classified by the Air Force as the GUU-4P before being quietly canceled. The SDN-556, a semi-automatic suppressed rifle developed by Psionics for special operations in the 1980s, produced an effective suppressed platform for the 5.56, but could not change the fundamental physics of a supersonic cartridge. The Advanced Armament Company M110 SAS suppressed sniper system, introduced in 2008, demonstrated what a large-caliber suppressed rifle could achieve at distance, but was chambered in 7.62 NATO, a full-power round that was effective and quiet at distance, but heavy, platform incompatible with the M4 that most operators carried as their primary weapon, and not convertible to subsonic operation without losing the long-range capability that was its primary justification. Each program demonstrated the requirement. None of them produced the single-platform dual-mode solution that the operational community needed. J.D. Jones at SSK Industries had understood the gap and started working on filling it in the autumn of 1992. Jones was, by his own description and the description of everyone who worked in the subsonic ballistics space, the father of modern subsonic rifle cartridge design. He had spent years exploring the boundaries of subsonic accuracy and subsonic terminal performance before anyone in the commercial or military mainstream was paying attention to the problem systematically. His Whisper family of Wildcat cartridges, copyrighted with first use on November 12, 1992, explored the possibility of using heavy .30 caliber bullets at subsonic velocities from rifle format platforms. The 300 Whisper, the first of the family, was based on the .221 Remington Fireball case necked up to accept .30 caliber bullets. It could fire 200 to 250 grain bullets at subsonic velocities with accuracy and effective range that the 9mm submachine gun could not approach. It could also, by changing the bullet weight, fire 125 grain projectiles at supersonic velocities from the same rifle. Jones had identified in 1992 the principle that the 300 Blackout would execute at commercial scale 18 years later. That the same cartridge case could serve both purposes if the bullet weight was varied to move the muzzle velocity across the sonic threshold. The 300 Whisper worked. Special Forces users who encountered it were impressed. The effective subsonic range with heavy bullets exceeded 200 meters with adequate terminal performance against unprotected targets. The supersonic loading extended the cartridge's utility to tactical rifle ranges. The platform was the familiar AR pattern, requiring only a barrel change from standard 5.56. Jones had, in a commercial and technical sense, solved the problem. The problem was that he had solved it as a Wildcat, and the consequences of Wildcat status for a military cartridge go considerably deeper than the simple fact of not being SAMI registered. When a unit procures a Wildcat cartridge, it is procuring something outside the standard military supply system. Standard military ammunition flows through the supply chain from the manufacturer to the depot to the unit through a logistics infrastructure that assumes standardized SAMI specifications at every point. It assumes that any round marked 300 Whisper from any manufacturer will function safely and reliably in any firearm marked .300. Whisper because the SAMI standard defines the dimensional and pressure specifications that enforce that interchangeability. A Wildcat cartridge carries no such guarantee. Dimensions can vary between manufacturers. Pressure limits are not officially defined. The head stamp markings may or may not accurately represent the cartridge's actual specifications. A unit operating a Wildcat cartridge in the field cannot assume that the resupply ammunition they receive will function identically to the ammunition they trained with, because no single authority has defined what that cartridge is supposed to be. For a peacetime recreational shooter, this ambiguity is manageable. For a unit conducting operations where a misfed or overpressure round is potentially fatal to the operator, it is not. Jones had additionally trademarked the Whisper name, which meant that the name itself could not be used on commercial ammunition produced without his license. This created a further barrier for commercial producers who wanted to load and sell the cartridge. They could produce ammunition dimensionally compatible with the 300 Whisper, but they could not call it 300 Whisper without Jones's permission, which created customer confusion about which products were genuine and which were approximations. The cartridge that had solved the problem in principle was not available in the form that mainstream military and commercial adoption required, and the structural barriers to making it available in that form were not resolvable without SAMI standardization that Jones had not sought, and that the Wildcat designation made impossible to obtain without the kind of formal application process that required a manufacturer rather than an individual inventor to drive it. When a member of what Robert Silvers described as the U.S. military's dark operations community approached him in 2009 with a formal request for proposal, the requirement was explicit, and the frustration behind it was the product of nearly 4 decades of unmet need. The customer wanted a .30 caliber cartridge that could be fired from a standard AR-15 or M4 platform. Same lower receiver, same magazine at full 30-round capacity, same bolt carrier group, in both supersonic and subsonic configurations, with a suppressor fitted, without any modification to the rifle between configurations beyond swapping the loaded ammunition. SAMI standardized, commercially producible at scale, safe to resupply through the standard military logistics chain. Silvers' solution was architecturally elegant in the specific way that solutions are elegant when they use existing components rather than inventing new ones. He took a standard .223 Remington brass case, the same case that 5.56 ammunition was produced from, available everywhere, produced by every major manufacturer, and shortened it. The case was cut and formed to a length of 1.368 inches, which created space for a .30 caliber bullet to be seated to an overall cartridge length of 2.26 inches, the same overall length as the 5.56 round that the standard AR-15 magazine and bolt were designed around. The shortened case retained the same head diameter and base dimensions as the 5.56, which meant the existing bolt face, the existing magazine feed lips, and the existing lower receiver geometry all functioned without modification. The case capacity was reduced by the shortening, an advantage rather than a limitation for the subsonic loading, where reduced propellant charges were required to keep the bullet below the speed of sound. The rifling twist rate of the barrel was the engineering detail that made both loadings function reliably. Standard 5.56 barrels use a 1 in 9 or 1 in 7 inch twist rate, optimized for stabilizing the lightweight high-velocity 5.56 bullets. The 300 Blackouts subsonic loading used bullets 2 to 3 times heavier, 200 to 220 grains versus 110 to 125 grains, and those heavy, slow-moving bullets required a faster twist to achieve gyroscopic stability in flight. Silvers specified a 1 in 8 inch twist rate that stabilized both the light supersonic bullets and the heavy subsonic bullets across their respective velocity ranges. The gas system was the engineering challenge that had defeated previous attempts at dual-mode AR cartridges, and that Silvers' design had to solve to achieve reliable cycling across both loading types. An AR-15's gas-operated mechanism functions by tapping propellant gas from the barrel as the bullet passes a gas port drilled into the barrel's exterior, channeling that gas back through a tube to the bolt carrier group and using the gas pressure to cycle the bolt. The system is calibrated for a specific range of gas pressure. Too little, and the bolt does not cycle fully, producing failures to feed or eject. Too much, and the bolt cycles too violently, producing battering of the components and accelerated wear. The 5.56's gas characteristics had been studied and optimized over decades of production. A cartridge with dramatically different gas pressure characteristics as a heavy subsonic .30 caliber load produces compared to a light supersonic 5.56 load would need the gas system redesigned to accommodate both ends of its operating range. Silvers addressed this through careful selection of propellants and charge weights that kept the gas port pressure within a functional range for both the supersonic and subsonic loadings, and through barrel gas port sizing that worked across that range rather than being optimized for a single point within it. The result was a system that cycled reliably on both loads without requiring the operator to adjust the gas system between configurations, the automatic function that made the dual-mode capability operationally useful rather than merely theoretically possible. SAMI approved the cartridge on January 17, 2011. Within months of approval, Remington Defense was producing both supersonic and subsonic loadings. Within a year, every major AR platform manufacturer was offering complete uppers in 300 Blackout. The cartridge moved from formal RFP to SAMI standardization to full commercial availability in approximately 2 years, among the fastest progressions for any military origin cartridge in the modern era. The terminal ballistics of the supersonic loading deserve specific examination because the lethality claim in the title is not merely about suppressed performance. The 5.56 round has a specific and documented limitation in short-barreled configurations. Its wound ballistics, fragmentation, and yaw are velocity-dependent. Below approximately 2,000 feet per second, the 5.56 fragments less reliably and wounds in a pattern more consistent with a pistol cartridge than a rifle cartridge. A 10-inch 5.56 barrel produces approximately 2,300 feet per second, compared to the 2,900 from a 16-inch barrel. And at the close engagement ranges where that velocity deficit matters most, the terminal performance difference is operationally significant. The 300 Blackout supersonic loading from the same 9 to 10-inch barrel produces a .30 caliber bullet at 2,000 to 2,100 feet per second, comparable velocity, but a bullet diameter approximately 25% larger and a sectional density that retains energy more effectively at range and penetrates more deeply at close range, regardless of fragmentation behavior. The lethality of the 300 Blackout supersonic is not dependent on the high-velocity fragmentation mechanism that makes the 5.56 effective. It functions through a larger primary wound channel that is consistent across the velocity range the short barrel produces. In the configurations where special operations and law enforcement actually use it, the 300 Blackout supersonic is more reliably lethal than the 5.56 it replaces, and then the same rifle, with the same suppressor, fires the subsonic loading and becomes an operationally quiet weapon. The Dutch Maritime Special Operations Force made the first publicly confirmed military adoption in 2015, equipping their operators with SIG MCX carbines in integrally suppressed configurations chambered for the 300 Blackout. The 5-year gap between SAMI approval in 2011 and the Dutch public announcement was the period during which the cartridge was being used by units whose operational security requirements prevented acknowledgement. American law enforcement tactical units began adopting 300 Blackout for their entry rifle programs as commercial availability increased through 2013 and 2014. The FBI's Hostage Rescue Team, the federal law enforcement agency's Tier 1 tactical unit, was among the early law enforcement adopters, along with SWAT teams in multiple major metropolitan departments whose entry teams found the short-barreled suppressed .300 Blackout configuration provided a combination of reduced report in structure environments and improved terminal performance over the 9mm submachine guns some teams had been using in the suppressed role. The cartridge's short barrel optimization, retaining full ballistic performance from barrels as short as 9 inches compared to the 5.56's preference for barrels over 14 inches, made it particularly attractive for vehicle-based units, for teams operating in environments with low overhead clearance, and for anyone whose operational geometry favored a shorter rifle without sacrificing terminal effectiveness. The civilian suppressor market's growth through the 2010s amplified the 300 Blackout's commercial trajectory in ways that had no parallel in previous cartridge launches. Civilian suppressor ownership in the United States had been growing steadily since the mid-2000s. By 2015, approximately 500,000 suppressors were registered in the United States. By 2020, the number had exceeded 2 million. Every suppressor owner who also owned an AR platform had a reason to consider a 300 Blackout upper. It was the cartridge that made the suppressor do what the popular imagination attributed to it, producing shots that were genuinely quiet rather than merely less likely to cause immediate hearing damage. The suppressor industry's growth and the 300 Blackout's growth were causally linked in both directions. Suppressor owners bought 300 Blackout uppers because the cartridge justified the suppressor. 300 Blackout adoption drove suppressor purchases because the cartridge's subsonic capability was the application that made the suppressor's cost and NFA registration burden worthwhile for a wider population of buyers than the rimfire and pistol suppressor market had previously reached. The cartridge reshaped what the suppressor industry produced. Before the 300 Blackout achieved mainstream adoption, the suppressor market had been dominated by rimfire and pistol-caliber suppressors. Rifle suppressors existed, but the 5.56's supersonic velocity meant that a 5.56 suppressor was a hearing protection device rather than a stealth device. And the market for hearing protection devices that added length, weight, and cleaning requirements to a rifle was limited by that specific utility. The 300 Blackout created a genuine market for rifle suppressors that changed what the rifle could do operationally rather than merely reducing hearing damage risk. Suppressor manufacturers developed products specifically optimized for the 300 Blackout subsonic operating envelope, shorter and lighter than the rifle suppressors previously available, prioritizing the subsonic performance rather than the marginal hearing protection of the 5.56 suppressed, and sized appropriately for the 9-inch barrel configurations that .300 Blackout operators preferred. The product ecosystem that emerged around the 300 Blackout: suppressors, short-barreled uppers, dedicated subsonic ammunition in both standard and specialized loadings, bolt-action configurations that eliminated the gas system variable entirely for maximum suppressor compatibility, was the most coherent integrated system the American commercial suppressor market had produced around a single cartridge. Sales grew 45% between 2018 and 2021. The cartridge had moved from specialty item to standard offering in the AR aftermarket in less than a decade from SAMI approval, a transition that the 6.8 SPC and 6.5 Grendel had never approached despite comparable enthusiasm at their introductions. The difference was the suppressor synergy. The 6.8 SPC and 6.5 Grendel offered improved supersonic performance over the 5.56, but did not change the suppressed operating envelope in a way that suppressor owners experienced as qualitatively different. The 300 Blackout changed what a suppressed rifle could do. That specific change drove adoption in a way that incremental supersonic performance improvement never had. The AAC Honey Badger crystallized what the 300 Blackout made possible and simultaneously created the aesthetic that the cartridge's cultural identity would be built around. Designed with a 6-inch barrel, an integrally suppressed configuration, and a total length of 24 inches with the stock retracted, shorter than most pistols when the suppressor was fitted, the Honey Badger was the physical embodiment of the one magazine, two weapons proposition. It never entered civilian commercial production in the form its designers intended. An ATF classification dispute in 2020 resulted in AAC's civilian version being ordered off the market, but its visual identity had already propagated through the firearms community, the special operations equipment media, and eventually into the broader popular culture representation of what a modern suppressed rifle looked like. The compact suppressed 300 Blackout configuration became the visual shorthand for a specific kind of operational sophistication in everything from military training documentation to video game concept art to streaming drama prop design. The cartridge is not without limitations that deserve honest statement. The choice between power and quietness that the 300 Blackout refused at the design level is deferred to the moment of loading rather than eliminated. A shooter carrying subsonic ammunition is not carrying supersonic performance, and the risk of accidentally chambering a 300 Blackout round in a 5.56 barrel, producing a dangerous overpressure event, is a documented safety issue that requires ammunition segregation as a non-optional operational discipline. The subsonic loading's effective range degrades beyond 150 meters in ways that the supersonic loading does not exhibit. The cartridge is what its designer said it was, a close to medium range solution to a specific tactical problem. And it is not a long-range cartridge in any configuration. None of those limitations change what Silvers built in 2010. It started as the choice no previous standardized cartridge had been willing to make. The refusal to accept that power and quietness were mutually exclusive from a single platform, built into a modified 5.56 case by an engineer who understood that the problem was not physics but standardization, and who found a path to SAMI approval that Jones's 300 Whisper had never been able to take. It survived a wildcat status barrier that had kept its conceptual predecessor trapped for nearly 2 decades, a Vietnam-era operational gap that the Army's own studies had documented and left unfilled for 40 years. A gas system engineering challenge that had defeated previous dual-mode AR attempts, and an ATF classification dispute that killed the most iconic platform ever chambered for it. It was adopted by Special Operations Forces who cannot be named within 5 years of approval. It was publicly adopted by the Dutch Maritime Special Operations Force in 2015. It was adopted by American law enforcement tactical units whose entry teams found nothing else provided its combination of compactness, quiet, and terminal effectiveness. It grew commercial sales by 45% in 3 years. It reshaped what the suppressor industry built and what suppressor owners bought. And it defined the visual and tactical grammar of the suppressed short-barreled rifle for a generation of operators and the popular culture that watches them. The 300 Blackout is not lethal just because it fires a .30 caliber bullet. It is lethal because Robert Silvers looked at the fundamental choice between power and quietness that had constrained suppressed military cartridge design for 40 years, decided the choice was false, and produced in a modified 5.56 case the engineering proof that he was right. A cartridge that fires quietly enough to be genuinely suppressed and powerfully enough to be genuinely lethal from one magazine in one rifle in whatever order the situation requires. If you enjoyed this, hit like, subscribe, and check out the next video right here.